Hello. This is the first of a series of 3 or 4 talks about how LLMs are made, so how chat AI is created. Uh, Understanding how they're made will make it easier for you to know what are the right questions to ask to AI and what are appropriate questions to ask, and it'll mean that you'll be able to use them better. My name's James Johnson. I'm an IT consultant specializing in web and AI, particularly for online marketing. I do mainly for B2B electronics sector and principally semiconductor companies. So how do you make a large language model? The very first thing that you need is an enormous amount of text. Um, This project, Common Crawl, has been going for 18 years. They basically crawl the web or scrape the web, downloading web pages, making those into archives that you can then download. So AI researchers download these very large archives of web pages. So you can see on the page here over 300 billion pages over the last 18 years. It's a really enormous amount of uh, text taken from the web. So they just save the raw HTML pages, and you can see on this page that if you download all of those archives, it's 88 terabytes of compressed HTML. So once you've got that, what do? Um, you basically clean it, extract just the text. If you're just focusing on English, perhaps just the English text. You remove low quality stuff, you remove all the porn pages, all of that kind of thing. You remove duplicates, you remove PII, personally identifying information. And this project, FineWeb, that's exactly what they do. And again, this is a research project. All of their work is open and you can download it all. And they've done exactly that with the Common Crawl data. So they go through this process of filtering it just to the highest quality text from all those web pages. And it's really interesting to read this process that they go through. And I particularly found this chart quite interesting. So this shows synthetic data contamination. In other words, it's showing how since ChatGPT was released, uh, the web has become contaminated with content that's actually made by AI. So that could potentially be a problem because, of course, if you're creating new models from the output of previous models, that could potentially affect how they work. You might want to try and filter out the AI generated content. So what does this actually look like? Again, it's a huge database. Here you see rows and rows of text, just random text. You can read it. It's all about all kinds of random stuff. This is page one of 483,000 pages like this. And so there's just an enormous quantity of text. Literally all the quality text on the web is here. So what do you do next? You take that and literally make it into just like one long string of text. And then statistically, you look at combinations of characters and you look for strings of characters, short strings of characters, which are common. And you look for maybe 100,000 of those common things. So, of course, the letter "the" is going to be very common in English. So that's a little string of symbols that you'll find over and over again. And this is a fun thing to play with. This is called Tick Tokenizer. If you Google for it, you'll find it. And in this, there's various different tokenizers that have been made. And we're using one specifically here that was used for encoding GTP4. So if I type in a string here, where's Barcelona? You'll see that here is that string tokenized. So with that statistical process of looking for the 100,000 most common strings of characters. So what you end up with is a string of numbers like this that represent that string. But you'll notice some interesting things. Although in this case we've got 3 words as 3 tokens, that doesn't have to be the case. And in fact, they're not just words. You can see it's actually space by Barcelona, space is. So what if we have Barcelona without the space? Is that tokenized in the same way? You'll see that that is 2 different, completely different tokens, right? Bar and Celona. What if we put it in all caps, Barcelona? So in this case, it's got 3 tokens, Barcelona. So it's not doing tokenization as we might do it. We might ignore the spaces and really make the tokens into words. It seems like the sensible way to do it, but this is working on a completely statistical way of doing it, and this is what you get when you just apply statistics to it. So what we end up with is we've gone from a long string of characters to a long string of tokens, just numbers, and that is what the base LLM is made with. So how do you do that? So we'll take a single token today. I am going, so I have 4 tokens. So what you do is you select tokens from that huge string randomly, and you put them into your neural network, and the neural network predicts the next token. So in this case, you'll see it's got 2 as being 4%, home as 2%, on as 3%. And so the result, the most probable one, is 2. And so you look at the text again, and if that's the correct answer, then all of the numbers in the neural network that got it right are increased a little bit. If it got it wrong, those are all decreased a little bit, right? So I'm not talking about the tokens now, the tokens stay fixed. I'm talking about within the neural network, there's a bunch of numbers which are called weights or parameters, and you alter the parameters during this training session. So we fed in this string, today I am going. It's predicted the next one, got it right or wrong. We've adjusted the parameters. Then you just feed in that whole thing again with the 2, right? And you predict the next one, and then you compare it to what's in the real data. And you just keep on doing that over and over again, a massive number of times. So the neural networks just starts off with a completely random configuration that's just full of random numbers. And you just keep on applying this. So you take out maybe 8,000 tokens at a time, but you don't do that once. You do that thousands of times in parallel, because you've got these very fancy chips that can do this kind of stuff in parallel. And you do that over and over and over again. And literally, it takes weeks and weeks of processing time to do this. And so it's incredibly expensive because it's a huge amount of processing. You only have to do it once to make that one base model. But it's just a very, very computationally expensive thing to do. So this is a little kind of interactive diagram that somebody has made of a visualization of how a neural network, a large language model like this works. But basically, you've got tokens going in, so numbers going in, and if you or one number coming out again, one token coming out the other end, and then you've got all these different bits in it. And I personally like to think of this as just being like a giant Excel spreadsheet, and indeed you can do this kind of thing in an Excel spreadsheet. With the size that we're talking about, it's impossible. But theoretically, you could make a huge Excel spreadsheet with multiple sheets where it's just all interlinked, and you basically have two types of cells. One which have numbers in them; those are the weights or the parameters, and others which have a calculation. And the calculations aren't actually complicated calculations. It's just doing some multiplication and addition, and then you apply a little function to it. And then you hand that on to the kind of next sheet in the Excel spreadsheet. Um, and yeah, but the thing is that these are massively huge numbers of numbers and calculations. So tokens in, the next token out. This is the paper that really started this current revolution, and this came out in 2016. So this really started off the GTP models from OpenAI. There have been since this a few other papers that we're looking at in next talks that have been, almost as big as this one. But this really kicked it all off. And the title "Attention is all you need," you can think of that as if you're thinking about the string of words essentially that's going into the AI, then to decide what the next word is, um, you don't have to take into account all of the words that have gone in previously. You can just pay attention to the ones that are really important in the context of the next word. So one way to think of the base model, this huge database of weights, is as being like a compressed version of all that text. You've kind of compressed it down into a much smaller size, and it's a lossy kind of compression. So what does a base model actually look like? How does it function? This website, OpenRouter, this is a really good service. There are others available. You can ask your LLM for things like OpenRouter if you want to use a different one, but this is a really good one. I'm not associated with it in any way. So basically you put credits with them, and they pay the large language model providers. So rather than having to have an account with Anthropic, an account with OpenAI, an account with Google, and to pay them all individually, you can just have one account with OpenRouter, and they handle all of that, and they charge like 5% or something on top. So it's really useful for being able to test lots and lots of different models. But today we're going to look at a very special type of model, the base model, the pre-trained model. So I want to emphasize that this is a model that's, you wouldn't use in any kind of production environment, probably. This is just the model before it's being trained, but we're just looking at this because it's interesting to see how they operate at this stage. So let's do that question again. I think I asked, where is Barcelona? So it's pre-trained, so it's just working on all of that text data that it's been trained on. This is a live test, so live IT demos are always risky. Where is Barcelona? It's responded, is the information trustworthy? Barcelona is located on the Mediterranean. What is latitude and longitude? So a very odd response, right? But you can imagine that this, what I find is often get responses that seem to be part of what's called the system prompt, and I think this might be something related to that. Or it could be a web page that was about, researching the answers to questions. So it's responded, is the information trustworthy? So the point here is basically this isn't the response we would expect from chat, but it might be a continuation of some kind of data or an average of the data that it's got from its training process. So if I do it again, is there life after death? Barcelona is TypeCon. So this must be from some kind of programming page, and then it has started with getting the question kind of right there, but with this weird stuff beforehand. So that we've got this kind of lossy, compressed version of the web. So it contains an awful lot of information. And if you prompt it in the right way, then you can get kind of it to respond how you would expect to the prompt. So in this case, I've said Germany, Berlin, England, London, France, and you would expect Paris next. And it has responded Paris, and it's carried on with a few others. So you can actually get, good responses out of it. And like I say, it's trained on an incredible amount of good quality information. So the information is all in there. We just don't have a kind of interface to get to it. Now what I'm putting in are the first few lines of the Wikipedia entry for Charles Darwin. And what I'm getting out here is, you can check this, but this will almost certainly be absolutely almost the exact same as the article itself. So if something is occurs multiple times in the training data, or if it's that there are things that when they're training they can mark particular types of data as particularly known to be trustworthy, then you can literally get the whole text out pretty much verbatim. So it's in there. Now this is a kind of fun one. This is the last one I'll do. These are the first two lines of the song from Frozen. It's not let it be, let it go, let it go. And a kingdom of isolation. It looks like I'm the queen, the wind is howling. These are probably the correct lyrics, at least up until this point. So, of course, one of the problems for the AI companies is that the large language models actually have an awful lot of copyright content in them. So this will be copyright Disney, right? So they have to set up the LLMs so that it doesn't actually provide this kind of response, because they don't want people getting copyright information out, because that opens up all kinds of legal problems. But it is actually within the model, because there'll be lots of pages on the web that has these lyrics on. Okay, so what are our takeaways? Large language models are really good at language. That's what they were made for. And the base model is a kind of a compressed version of all that text on the web. So it kind of is a compressed version of language, as well as the kind of facts in those web pages. But it's not good at arithmetic and spelling and that kind of stuff. And there's a whole bunch of stuff that they're not good at. And so, I think hopefully you've got a little bit more of an intuition as to how the kind of base brain of a large language model is created. And you can see that they're not really thinking, they're completing the next token. but because of the way they're built on this huge amount of data, very often what comes out is quite useful, and sometimes because it's using language that we use, it can seem to be giving an intelligent response. But they're not really intelligent, and that really comes out sometimes when they say really stupid things like, they can't count the number of letters in strawberry, or can't do a simple sum. So the large language model providers need to do all kinds of things to make sure that they don't say these stupid things as much, and we'll look at that in our next talk. Randomness is a feature of these large language models, so it doesn't always choose the most probable next token, because then it would always produce the same bit of text to whatever you typed in. And with chat, that the impression you get when it does that is that it's not actually intelligent, right? It's just a computer responding from a database, and that's not what they want. So if you're looking for a deterministic response, if you're looking for a specific response, as you are when you ask how many R's in strawberry, large language models aren't actually a very good way to do that. Finally, OpenRouter, I think, is really worth playing with. So you can upload a little bit of money there, and if you don't use the expensive models, it will last a long time. And it's really worth just going in and looking at the different models, or maybe with your whatever your favorite chat AI is, you can ask it what it suggests for you to look at in OpenRouter, and do a bit of back and forth of experimentation like that. And I think that's really worth it. So in the next sessions, we're going to look at the next step of making a large language model, which is training it, and training it so that it can respond in a conversational way. So that'll be up in about a week's time. Thank you very much.